Hey there! Just starting in now with total solar eclipses. A solar eclipse is when the moon covers the sun, and solar eclipses are partial when only part of the sun is blocked, and total when it's all is blocked. And we call them annular, not because they happen every year. Annular eclipses when they make an annulus, which is a ring, or it's total, like in this image from 2017. The reason eclipses don't happen every month is because the orbital plane of the moon's orbit with respect to the Earth's orbit around the sun is tilted by about 5.2 degrees. That means that the shadow of the moon does not always come across the Earth's face at new moon. So you see on the left-hand side, that's the position of the moon for new moon, if we're looking across the plane of the Earth's orbit and the moon is in exactly the same direction as the sun, except it's inclined away and up by 5 degrees. And that would be a new moon that is in the direction of the sun, but above it in the sky. And there will be no eclipse at that time. So let's see when we get eclipses. These are called eclipse seasons, and this diagram is really not to scale. There's a time of year during which the solar and lunar eclipses are possible. Lunar eclipses don't occur at every full moon, and solar eclipses don't occur at every new moon. And that's again because the moon's orbit is tilted 5 degrees with respect to the Earth's orbit. And the eclipses for total solar eclipses can only occur if the sun, moon, and Earth are in a direct line. So because of that tilt, sometimes it's above the plane of the Earth's orbit, and you're not going to get an eclipse there. And sometimes it's below the plane of the Earth's orbit, and you're not going to get eclipse there either. But it might happen when the moon is at the node of the intersection between the ecliptic, the path that the Earth takes around the sun, and the moon's orbit around in its orbit. So those are two planes and they intersect in a line, and we call that the line of nodes. And so if the moon is new and at a node and at the ascending node, then it will be a total solar eclipse if it's exactly at that node and the node is lined up. So we have what's called a syzygy, and the syzygy is the conjunction in the sky viewed from behind, say, the moon, Earth, and sun. All right, but this doesn't always happen. When the line of nodes is in this position, the moon might be at some other phase. It might be somewhere else. It has to be at this position, and it can be at any of these positions. And that's why it doesn't happen all the time. So this diagram is kind of deceptive because it makes it look like that the moon is always at this one place at this time. It's not. It can be when the nodes intersect, it could be anywhere on that orbit. It just has to be at that place. Likewise, it could also be here. Actually, it happens 3 times a year because the draconitic month, which is the month according to the line of nodes, that node line precesses with a period of about 18.6 years in the opposite direction of the moon's orbit. Therefore, the draconitic month is faster, and therefore the line of nodes will point at the sun 3 times a year. And if the moon is exactly at new moon at when the nodes are lined up, then sure, we'll get an eclipse, a total solar eclipse. So let's look at what that looks like. A total and partial solar eclipse happens when the shadow of the moon lands on the Earth. The black spot is the only place on Earth where you will see a total eclipse. The gray spot is where you'll see a partial eclipse. So it's the dark gray triangle that's going to cast is called the umbra, and that is the darkest spot in the moon shadow where the sun, if you're anywhere in the umbra, the sun is completely covered if you're behind the moon. But if you're in the larger gray triangle, you're in the penumbra, which is wider, and the sun is partially covered. All right, the other thing that it can be is an annular eclipse. And again, annular eclipses do not mean that they happen every year annually. It means that it is an annulus. An annulus is another name for a round ring. Annular eclipses are a special form of partial eclipse where the moon is too far away to fully cover the sun. Wait a second, how is this happening? That's because the moon's orbit is elliptical, and so sometimes it's farther and sometimes it's nearer. So the moon has to be at its closest point in its orbit in order to have a total solar eclipse. If it's at its farthest point in its orbit, then it will be an annular eclipse. So we have kind of three regions. Again, the umbra is the darkest triangle, and so if you have a spacecraft and you're out in space and you're right in there, yeah, you're going to see an eclipse. The whitest triangle is where the two penumbral triangles merge, and it's not fully covered. All of these things are penumbral eclipses. It's just a really special form of the no, penumbral eclipse, where the sun is partially covered, but the moon makes a very large spot that almost covers the entire sun. Next, we have the shape of the shadows on the sizes of the Earth. If the moon is pointing straight overhead, there will be a pure circle. But because the Earth is a sphere, and it's not flat, it's because it's a sphere, the shape of the shadow of the moon will be spread out across a spherical surface, and so it won't be a circle, it will be an oval. So yet another way we can determine that the Earth is a sphere. Take that, flat earthers. Let's look at some future eclipse tracks. There's one coming up in April 8th of 2024. That's not far from today when I'm recording this, but it's possible that you'll be watching this well after that time. In any event, that will be a huge, huge thing. But if you miss it, there will also be one in 2034, 2044, and 2045. So watch for those if you happen to miss the one in 2024. There's another one 9 years later, and then 10 years after that, and then right 1 year later again. The 2033 one is only in Alaska. The 2044 one is in northern Canada, so you're gonna have to take a trip. And unfortunately, for people who wish to see that one, it'll probably be cloudy. That's usually how that flies. Just have to wait till 2045, 20 more years from the time of this recording, 21 years, to get another one that'll pass straight across the United States. And if you must go even further and you're a little person when you're hearing this, a tiny baby boy or baby girl, then you may get to see these much farther in the future. And in this deep, deep, deep future, I believe in 2099 is the farthest one out that will pass across there. So the United States will get a bunch in the coming times, but you may have to wait a very long time to see them if you don't wish to leave the continental United States and North America. But let's see what's happening in the rest of the world. In the rest of the world, we have a lot of upcoming eclipses. In this diagram, the red ones are annular and the blue ones are total. And if we see August 2nd of 2027 going straight across the middle there from kind of going from an up to down, it first goes through the Straits of Gibraltar and then passes across northern Africa and down through, I believe that's going through Egypt and Cairo, which is amazing. So that would be great. So there will be some amazing pictures of the eclipses the eclipse possibly from the pyramids way out there in the Egyptian desert. And there'll also be some beautiful, beautiful images coming in from the Straits of Gibraltar in Spain. And then there's also one that kind of goes lower to up. That's in March 20th, 2034. That'll be going across Central Africa and going across the hottest parts of the Saudi desert and into Iran and into Afghanistan before it gets to Western China. That'll be amazing. So perhaps that's something other people will see. Maybe you get the chance to see it. Take a flight. Next, let's go across and notice something truly fascinating. 2028, 2030, 2037, and 2038, Australia gets 4 eclipses in 10 years. Wow, That's going to be amazing for them. And November 25th, South Africa gets it as well, but amazing that Australia gets 4 in the coming decade. So in the next 14 years from the time of this recording, you'll be able to see that. And the most amazing, I think the best one of all is, of course, just December 26th, 2038. It'll be what, the day after Christmas, so that'll be fun for them. But if you wish to, you can also take in 2039, go a little bit further south and go into Antarctica to see that total solar eclipse in Antarctica. That would be amazing. And now if we go back north, we would see in August 12th of 2026, you go to the North Pole to see that one, or you can see it from Spain, again from Spain. Amazing, good stuff for them. And then it goes through Iceland. So that might be an amazing time to go see that and take a trip to Iceland or even Greenland. See how it goes all the way through Greenland? September 2nd of 2035, it goes through central China, North Korea, and Japan. So that will be some amazing time. So be a great time to be in Japan. Um, then we go back over to North America and we see, of course, in 2033, that's the one in Western Alaska. And again, the one in April 8th of 2024 coming up really soon. So there's a bunch that'll happen between 2021 and 2040, and those are all those previous maps were given by were created by Fred Aspanak at NASA, the Goddard Space Flight Center. That's for Goddard Space Flight Center. And so this is just some amazing stuff that Fred has been doing over the years, and he's a real eclipse chaser. Make sure you get a chance to see it. You got to plan for it. They're amazing times. Why? Because you see this. Here's an image that from Glendo, Wyoming on August 21st, 2017, taken by Vishnu Reddy. And Vishnu was standing right behind me in Glendo. And so he offered to give me these images. So this was a amazing set of images. And here they are. Again, this is during totality. And you see in a photographic image like this, the corona of the sun, which we talk about what the corona is in my module about the sun. But this is what it really looks like through a camera. But it looks different naked eye. We don't really have to, you shouldn't look at it naked eye. You should always have some sort of protection. But you do see the corona in the sky, which is amazing. That's just astonishing. It does get dark when it goes to totality. It's absolutely beautiful. I'll be showing you this in just a second. So again, a total solar eclipse is when the lights from the sun, the disk of the sun is completely blocked by the moon. And it is interesting that the moon's size is exactly the same as the sun's size in the sky, and we'll get to why that is later. So an annular solar eclipse, here was the one that just happened on October 14th of 2023. And this is by JAXA and NASA, and it was taken by the solar telescope Hinode as the moon came between it and the sun. And so this is from science.nasa.gov. So go there and look for this image from JAXA and NASA. Next, this was taken to National Park Service by Kevin Dostaxler, October 14th, and from the desert Southwest. And this is a progression of all the images taken in together. And this is the umbral shadow is seen from space. And this is a really interesting thing. And I believe this was aboard the International Space Station on November 13th of 2003. And this was downloaded from NASA's Goddard Space Flight Center. When you go see an eclipse, solar eclipse, make sure you do it safely. First, look over on the left-hand side, get yourself those eclipse goggles. You need that, or else you're gonna, you'll damage your eyes. The sun is really bright, and just because the moon's covering it doesn't mean that it can't damage your eyes. And it's really wonderful to watch the moon go across the sun. And if you have these kind of glasses, you will be able to see the chunk taken out as it happens. Also, if you're really smart, you can put a solar filter on top of a little junky telescope that you don't mind burning the interior optics of and projecting it to the side so people can watch it without having to look through little glasses. Or you can make a pinhole telescope, like that diagram. It basically is a cardboard shield with a little pinhole, and you typically want to make that pinhole out of foil, so it's a very tight pinhole. It's better if you put it inside some sort of box in that thing. Like the kids in the middle, they won't see the corona, but you would see the corona if you put the pinhole camera inside a box and then look inside the box from the side. At the very minimum, if you're going to go see a solar eclipse, get some eclipse shades.